This video consists of a simple implementation of a conveyor belt that we made to work in conjunction with a board for a manufacturing automation assembly line implementation. We have here the setup that we are using for the conveyor belt. As you can see, you have a frame that houses a shaft on one end, and we have another frame here which houses another shaft which is connected to a servo motor. This continuous servo is provided by parallax. Once this has been implemented, we have used a belt that's made solely out of sandpaper, and at the bottom you can see that it uses duct tape to hold it together. We have used duct tape to take most of the tension of the belt when it is stretched out like this. The sandpaper provides most of the friction that's required for transferring material over it. As I mentioned earlier, this implementation is being used in conjunction with a board. The board has been fitted with a gripper that carries the raw material that will be dropped off at this end, and by operating the conveyor belt, the raw material will be transferred from this end slowly down along this line to this end. In addition to this whole assembly, we also have two sensors, one over here at the beginning and one over here at the end. These sensors are known as sharp object sensors, and these are available if you just search online or in Google. You'll probably be able to find it. These are usually used as distance measurement object sensors, but here we have used it as object detectors. So once a material is placed over here, this object sensor detects the presence of that material and turns off the raw material and awaits instruction from the board saying that it has released the material and it is clear to proceed operating the conveyor belt. Once the conveyor belt has been started, the material goes down here. The speed of the conveyor belt is variable to represent any kind of manufacturing process that goes on in between. So the intent is to optimize the speed based on different manufacturing processes as the user may deem necessary. And once the product has finished, the raw material has finished all the processing, it reaches this end where another object sensor detects it and stops the conveyor belt so that the finished product can be removed by the same board. As you can see, the sensors and the servo motor has been connected to a development board which is supplied by parallax. The development board itself has a microcontroller which works on a BS2 platform. This BS2 platform is also provided by parallax. Now we also see two ADCs which detect the signal sent by the object sensor, and by converting the analog signal from the object sensor into digital data, we are able to obtain information of whether an object is present in front of the sensor or not. And using good programming practice, you are able to control effectively the motion as well as the speed of the conveyor belt. Now that the functional implementation of the conveyor belt has been understood, let's just see how the operation is done. By turning on the conveyor belt, you can see that the belt starts moving. The rate of motion we have calibrated at around 2 minutes for one end to the other end. So if a material is placed here, it takes approximately 2 minutes to get to the other end. As I explained earlier, the sensor detects the presence of raw material. As you can see, when an object is placed, the conveyor belt comes to a standstill. Now it awaits instruction from the bow boat to execute the rest of the motion. Now, since the bow boat is not communicating with the controller, we'll just remove it from in front of the object sensor to simulate it. By placing it outside the field of the sensor, you can see the conveyor resumes normal operation and the conveyor belt moves out. For those who are really interested in making a conveyor belt, we actually came across a difficult time searching for good material for implementing this. As explained earlier, we have used sandpaper and a continuous line of duct tape to implement this. This is a very effective and simple way of doing it. It is also very economical. Instead of using any rubber belt or any other kind of expensive material, this is a very simple and robust implementation for a belt. Now that you can see that the raw material is slowly approaching the other object sensor, it should be able to detect the presence of the finished product and stop on its own. Yep, as we expected, the raw material has come to a stop. Now, using the bow board, we are able to lift it off of the conveyor belt, and as soon as we lift it off, we can see that the conveyor belt resumes its operation. So, like we mentioned earlier, this is a very easy and effective means of implementing a conveyor belt. Thank you.